Hi everyone, I welcome you all in tutorial 10 of my Etabs software training series. In my last tutorial, I explained how to design the building in Etabs. If you haven't watched my previous tutorial, don't worry, I will paste the link in video description so you can access to my previous tutorials. If you are new to my channel, please subscribe to it and press the bell icon so you can be notified on my next uploads. In this tutorial, I will discuss the most important topic, which is how to prepare the drawing sheets and present it to the client using Etabs data. I will cover both methods. One is manual method of preparation of the drawings, and the second one is auto method, which is feature of Etabs software known as detailing, CSI detailing. You can also do detailing of your structure by downloading CSI Detail software, but I am doing it on Etabs 2016 as Etabs 18 does not have detailing feature. So let's begin. So in order to do the detailing of your structure, first you have to set the detailing preference and rebar selection rules. To do that, first go to the detailing menu, and from there you have to select detailing preferences. And I would always suggest to keep it as a default because the units are always the same which you have chosen at the start of modeling the structure. After that, again go to the detailing menu, and from there you select rebar selection rules, and from there you choose beams. Now here you can see the two options here, one is non-seismic and another is seismic. Since we are designing our building considering the seismic forces, so you have to click this seismic, and from here you have to choose the bar size. Now you can see under the longitudinal bar, you can see there are a number of items written, which is A, B, C, D, E, F, G, H, and the steps are divided into the zone A. So let me define it to you from the longitudinal section. So as you can see, this is a typical elevation of continuous beam where A and F represents the top and bottom bar respectively. G and B represents the steel reinforcement at the start of the beam near to the supports. So G represents for the bottom reinforcement or extra reinforcement near to the support at the bottom, and B represents the extra reinforcement at the support at the top. Similarly, H and D represents the reinforcement at the span 2. Similarly, at the top, and H represents the reinforcement at the bottom at the span 2. Similarly, C represents the top reinforcement as the span 2. And your continuous beam is divided into 3 spans. So you can also see it from here, typical beam elevation of 3 span beam. Similarly, you can also see for two span beams from here. Now the spans will be two, one span and second span. So this is the typical concrete beam elevation for two spans. So here you can also see reinforcement is designated with the number of alphabets. So again, A and F represents the top and bottom reinforcement. Similarly, B and G represents again the top and bottom reinforcement, or you can call it as an extra reinforcement near to the supports. Similarly, D and H, again they are the extra reinforcement at intermediate supports. And similarly, C is the top reinforcement on the second span. So you can also read notes from here. For stirrups, you can see the stirrups has been divided into the number of zones. So zone A, zone B, and zone C. Zone A is near to the supports, on which spacing is smaller because it supports our beam experiences higher shear force. Similarly, zone B represents the zone which is after the zone A. So here the shear force is a bit lower, so thereby you can see the spacing is a bit higher compared to zone A. And similarly, zone C, where our shear force is lower, it's the midspan of a beam, so the spacing between the stirrups is smaller. So that's how our beam is divided into the three zones in order to calculate the shear reinforcement. So let's look at the column. This is a typical elevation of a column. Again, the column is divided into three zones. You can see zone A, zone B, and zone C. Zone A and zone B are near to the supports, where spacing is smaller between the shear reinforcement, and zone B is considered as the mid span of a column, where the spacing between shear reinforcement is a bit higher. Now go to the detailing. From detailing, you choose rebar selection rules and choose beams. And since we are going to design our building for a seismic zone, considering the seismic forces, so you have to choose the seismic. And from here, smallest bar size, so I am considering as we are designing for a residential building, so the smallest bar size I am choosing is number 4. You can also change it from here if you want to keep it number 5, so you can do it. Similarly, for all type of the reinforcements which I have just shown you, what does these letter indicates from the typical elevation plan of a beam. So I'm just keeping it as number 4 for all the types of reinforcement. Similarly, for stirrups, I will choosing number 3 bar at zone A, zone B, and zone C. Similarly, the largest bar size is kept as number 9, and for stirrups, it is number 6 bar. And preferred bar size, you can also choose it from here if you want to select preferred bar size is number 4, so you can keep it as number 4, but I am leaving it as default. Similarly, from bar quantities, minimum number of bars, as I just told you, A is the top reinforcement, so the minimum number of bars required for the top should be 2, so I have written here as a 2. Similarly, F is the bottom reinforcement, so the minimum number of bars required for bottom reinforcement is 2. You can also change if you want, and leave the rest as by default. So now you have to do the same thing for the columns as well. So go to the columns, then choose seismic from there, and from here I am choosing smallest bar size as number 4 again, the largest bar size 10, and preferred bar size is number 5. So you can also change accordingly. Similarly, as far as lateral ties are concerned, so for lateral ties, smallest bar size is kept as number 3, largest bar size as number 6, and I would like to choose preferred bar size as number 3. So now here is a bar length. So splice, I want there should be a splice bar after every 2 story, and minimum number of bars as 4. Settings, keep the rest of settings by default. Click OK. So why I'm doing this, because most once we do the detailing from the Etabs, I just want the drawings which are being generated from the software, and I will edit manually all the data and calculate manually the number of parts and reinforcement which is required for the structure which we have designed. So once we are done with the detailings, now you have to go to the detailing bar again and click start detailing. As you can see, our detailing is done. So from here, from Model Explorer, choose the detailing, and you can see the number of drawings. So for example, I want to see the floor framing plan of story 2. So our floor framing plan is ready. If you want to export this into AutoCAD, so you just need to right click from the mouse button and click the export view. From here, choose it directly and just click start export. So once you are done, press OK, open your AutoCAD, go to the file menu, click open. So from here you can see floor framing plan is ready, so click open, and yes, see, within seconds all the drawings related to floor framing plan is being generated by Etabs with a single click. Now let's go to the Etabs again. So you can also see the sectional elevation. The thickness of slabs at 6 inch and all the beams are shown. You can also export the most important sheet in detailing which we require is rebar, beam rebar detailing and the column rebar detailing. So to do that, what we have to do, we have to go to the beam details, then select for the concrete beams and go for schedules and tables. From here you choose rebar table. So from this table, as you can see, this table is divided based on the stories. So this represents the second story. Similarly, 3CB1 represents the third story. Similarly, the fourth story. If you go to this concrete beam rebar table 2, so it will start from your plinth beams. Okay, so plinth beams, then story 1 beams, story 1 beams, then story 2, and finally the roof beams. So for example, so let's consider this beam. So first see from the beam column floor plan what name has been given to this beam by the Etabs. So let's go. So this is 3CB1S1. So that means beam of story 3, beam 1, span 1. Similarly 3CB1S2, 3CB1S3, because as you can see this is a continuous beam. So for this, if I want to see the details of these beams, so you just go to the concrete beam rebar table, and from here you choose 3CB1. As you can see, this beam is divided into the number of spans 1, 2 and 3 because it is a continuous beam. If you compare it with 3CB3, it has only one beam. Now let's see which is the 3CB1, 3CB3. So 3CB3 is, this is span 1. So that's why you will be only getting the data of only one span. So let's focus on our beam. So it's 3CB1. So A is our top reinforcement. So for top reinforcement we'll be requiring two number of bars of number 4 size. You can also calculate it because our required area is 0.4. So you just 0.4 divided by the number of 4 bar size. So the area of number 4 bar is 0.2. So it's 2. Okay. So we will be requiring number 2 bar. Similarly, here you can see number 4 bar slightly the area is higher, so we will be needing 3 bars, but here the Etabs is going on the safer side, so that's why it has chosen 4 bar, but you can change it accordingly. Actually here it should be 2 bars, but I don't know how this Etabs is calculating the bars, because if you see the cage view, reinforcement cage view of this beam 3CB1, so here you can see only 2 bars are placed at the top and the 2 bars are placed at the bottom. So actually here it should be 2 bars. So that's how you have to calculate the steel reinforcement. Just see the area. Similarly, now what you have to do, you have to take this data and come to the AutoCAD sheet. I have already prepared the cross section of this beam. This is a rough cross section. As you can see, I have placed bottom bars, 2 bars, 2 bars at the bottom, 2 bars at the top. So that's how you have to prepare the longitudinal view of the beam. Now I can see 3CB1 for span 2 you will be requiring number 1 bar. So this is A, B and C. C means top reinforcement at mid of the section. D, so what does D represents? So D is extra reinforcement at intermediate support. Should be needing an extra reinforcement 1 of number 6 bar. Similarly, the bottom reinforcement R is similar to the previous span. So come to the AutoCAD. So here you just have to provide the extra reinforcement at intermediate support. This is your section 2. You can also place uh, so here you can see we have provided an extra reinforcement at the intermediate supports, and in order to draw the correct diagrams you can also refer to the standard details. So in this way you can prepare your drawings considering the values which are given in beam rebar table. Now let's look at the column details. So go to the column details. From here click columns, it's framing plan, concrete column layout. So our column, you can see all the names are designated same because our column is getting the same reinforcement. We can also verify from this model. Just switch it into the elevation mode. So as you can see, from bottom to top we are getting the same reinforcement area. That means the group of columns is same, so that's why the Etabs has named it CC1 for all the columns. You just check other elevations, so you will be seeing the same reinforcement area which is being calculated by the Etab. So that's why the column type the column type is 1 at the column layout. So it's good. It will be easy for us to detail it. So CC1, so you can see the area required for this column is 1.440. Now go to the Excel sheet. In order to calculate the number of bars, the area required is 1.4400. I am using number 4 bar for our column, so divide by area of 1 bar. So the required number of bars are 7.2. So we just approximate it and consider we require 8 number of bars. Okay, 8 number of bars. So again go to the AutoCAD. Here I have already modeled the column cross section considering 8 number of bars are 4 by 8 inch dia. Now as from our model we can see from foundation to the roof level the column size and reinforcement is same. So once you present this data to the clients, you have to make this kind of table. From here you have to on this table you have to write concrete strength, then remarks. All columns rings are 3 by 8 inch dia at 4 inch center to center. So how I have calculated this spacing, again you have to see the column schedule. So from here I have got this data which is number 3 at 4 inch dia for zone A, zone B and zone C. So that's why you always go for manual methods and the auto methods. So it will save your time. So for foundation to ground floor, again our column size and the reinforcement required are same. From ground to first floor, so again the reinforcement and column size is same, and from ground floor to first floor we will be requiring 8 number of bars of 4 by 8 inch dia for our column. So that's how you have to. And from roof, there is no column at the roof level, so I just put these days. So that's how we have to prepare our column and beams. If you want to see the gauge view of column, how the reinforcement will be done in the column, so you can see that's how once you construct our column in the field, so you have to provide this kind of reinforcement. So if you want to export this data or all the sheets which you want to export into the Etabs, you just right click and press export view and start exporting, then done. So as I told you earlier, for detailing we will be requiring beam rebar table. So you just right click export and start exporting. It's done. Go to the AutoCAD, open. So concrete beam rebar table, click open. So as you can see, within seconds we have exported this beam rebar table. So we just need to do the editing, a bit editing, and normally what structural engineers do, this name is it a one, for example beam 1. So this is your beam 1. Okay, now come to the cross-sectional elevation of beam 1. So from here you provide the same bottom and top reinforcement throughout the elevation, considering the maximum value. Let me switch it into the story 2. So from here you are getting bottom reinforcement as 0.360, 0.120 and 0.561. So the 561 is the higher value at the bottom reinforcement. So choose this value for all the spans. So if you consider 0.561, so come to the Excel sheet 0.561. For this I am choosing number 5 bar. So I'll be requiring 1.8 number 2 bars for 5-inch tire. Similarly, now go to the top 0.138, 0.248, 0.139. So 0.248 is higher value. So choose this value and calculate the reinforcement. 0.248 divided by, now I am choosing number 4 bar. Again I will be needing 2 bars of number 4 size. So that's how you have to do and prepare the sheets considering the Etabs data. So guys, this brings to the end of today's tutorial. If you find this tutorial useful, please do like and share. And if you have any comment, please comment in the comment section. And also let me know what you want to learn in my upcoming tutorials. Thank you and have a nice day.